Look at this. Isn't this a great night? Look at that. Look at those planets moving around. Oh my, a shooting star. Good luck with that. Wow. You know, I've got to tell you that the solar system is just really a playground for scientific investigation. And there's so many questions that we can ask about the different planets. And I want to actually show you how we can actually understand the planets better. Check out this interesting challenge for us. Here's the question. About how many times greater is the mass of Saturn than the mass of Earth? How many times greater is the mass of Saturn than the mass of Earth? And our challenge is to see if we can write that answer in scientific notation. So here is actually a chart which presents the mass of the planets in the solar system. Here's the planet, here's the approximate mass, Mercury, Venus, and so forth. And now the question is, we want to take a look at the ratio. We want to compare how many times greater the mass of Saturn than the mass of Earth. So the mass of Saturn is here, and the mass of Earth is here. And so we want to look at the ratio of the mass of Saturn, which is this number, 5.69 times 10 to the 26 kilograms, and look at that with respect to, as a ratio of, the mass of the Earth, which is 5.97 times 10 to the 24th kilograms. And so now the question really evolves to, what does this ratio equal? Now, it's written in scientific notation. So what do? Well, what we can do here is literally, since there's multiplication going on here, we can actually consider each of these separately. So what I'm going to do is I'm actually going to look at 5.69 divided by 5.97, and then I'm going to look at 10 to the 26 divided by 10 to the 24th. This will involve actually a calculator. So we'll actually have to use a calculator for this one. And so what would the answer be? Well, 5.96 divided by 5.69 divided by 5.97 is equal to 0.9531 and so forth. Keeps going. So I should put approximately. Now, what about this? Now, this is one that we don't need a calculator for, because since this is a power of 10 and this is a power of 10, all we have to do is subtract the exponents. Take the top exponent, the exponent in the numerator, and subtract off the exponent in the denominator. So 10 to the 26th, and I divide by 10 to the 24th, I'm left with 10 to what power? Well, 10 to the 26 minus 24, which is 2. And what about the kilograms? The units, notice, they cancel as well. So in fact, this is going to be unit-free, which is correct, because it says how many times greater is the mass of one thing to the other thing. So that should just be a number. It shouldn't have units. So notice that the math works out beautifully if you're really careful. Even the units go away as they should. So that is the answer. Now, it's not written in scientific notation. I want this number to be between, 1 and 9, something. So not great. So I need to slide this decimal over. I'd like to do a little slide. A little slide the decimal over to here, which would involve me actually doing what? Well, it would involve me actually eating up one of the two factors of 10 I have here. If I remove one of those factors of 10, so I only have one of them now, and multiply this by that 10, it slides over. And so, in fact, what I see here is I could write this as 9.531 something times 10 to the first power. And see, I move the decimal over 1 unit to the right by using one of the two factors of 10 I had here. And now this is in scientific notation. So that's how much bigger, in fact, how much many more times greater the mass of Saturn is than the mass of Earth. Isn't that cool? Very, very cool. So it's the power of these things in scientific notation.